Welcome to Chemistry A to Z, back-to-back dose of chemistry.
Please subscribe, like, share, and comment. Welcome, and our topic for today is naming of coordination compounds. Coordination compounds or complexes are molecules that have a central metal atom bound to ligands. A ligand is an atom, ions or molecules that donate electrons to the central metal atom. That is, ligands are what? Lewis bases. Basically, a coordination compound is made up of the coordination sphere and the ionization sphere. Now, the coordination sphere consists of the central metal ion or atom and its attached ligands, while the ionization sphere consists of the ionic species. Now, the total number of ligands will give us the what? Will give us the coordination number. Cationic complexes are complexes in which the coordination sphere is a cation. In anionic complexes, the coordination sphere is an anion. The coordination sphere is neither cation nor anion in a neutral complex. Homoleptic complexes consist of similar types of ligands. Heteroleptic complexes consist of different types of ligands. In mononuclear complexes, the coordination sphere has a single transition metal. There are more than one transition metal ion in the coordination sphere of polynuclear complexes. Anionic ligands end with O, while organic and neutral ligands retain their customary names as neutral species. As can be seen on the screen, the ligands in black are the anionic ligands, while the ones in red are the neutral ligands. In cationic complexes, ligands are always named before the central metal ion. When there are more than one monodentate ligands, prefixes like di, tri, tetra, penta, hexa, hepta, and so on are used to indicate the number of ligands. Negative ligands are named before neutral ligands. When there are two or more similar ligands, the ligands are named alphabetically without considering the numerical prefixes of the ligands. For polydentate ligands or ligands which already have a prefix, prefixes like bis, tris, tetrakis, pentakis are used, followed by the ligand name in parentheses. For anionic complexes, the central metal atom will carry a suffix 8 followed by the oxidation number of the metal using Roman numerals in parentheses. Oxidation number of 0 is indicated by 0 in parentheses. Priority is given to the Latin name of the metal if it exists, except for mercury. In naming salts, the cationic part is named before the anionic part. Polynuclear complexes are named by identifying the bridging ligands with a prefix letter mu. In naming this compound, we need to calculate the oxidation number of cobalt, which is X. Then we have 4 neutral ligands here, and each of these neutral ligands have oxidation number of 0, so that will be 4 times 0. Then we have 2 chloro groups here. We have 2 chloro ligands here, so each one is -1, and we have 2. Then equal to what? 1. This positive charge that you have here equals to 1. So by the time you solve, you have what? X equal to what? 3. So in this compound, cobalt is 3. So how do we name this compound? Mind you, this is a cationic complex. So in naming this compound, we have to what? Name the negative ligand before the neutral ligand, and this is the negative ligand. So the name will be what? Dichloro. Then we have 4 amine group. That will be tetra amine cobalt 3 ion. So that's the name of the complex, dichloro tetra amine cobalt 3 ion. Now for the second compound, we also have to name, this is a compound, it's more like a salt. So we name the anionic, we name the cationic part first before the anionic part. So we are naming the coordination sphere before the ionization sphere. So in this one, we'll name this first. So that will be dichloro, because it is a negative ligand. Dichloro tetra amine platinum. So what's the oxidation number of platinum here? It will be what? It will be 4, because you have -1 times 2, -1 times 2. So that will be what? -4. Platinum 4 chloride. Platinum 4 chloride. This is an anionic complex, so the central metal name will end with ATE. So we have to start the naming from here: tetrachloroplatinate 2 ion. So we have tetrachloroplatinate 2 ion. This is another anionic complex, so the central metal name will end with ATE. So in naming, bromo comes before cyano because B comes before C. So we have dibromo tetracyano. So Sn is tannum, so it becomes tannate 2 ion. In this example, we have to name the cationic part before naming the anionic part of the compound. So in naming the cationic part, we have hexaamine chromium 3. Now, while naming the anionic part, the name of the central metal atom here, which is cobalt, will end with ATE because this is the anionic part. So we have hexacyanocobaltate 3. Now for the second example, we have 2 neutral ligands. So we name the amine first before the aqua. So that will be diamine diamine tetra-aqua chromium 2 ion. Now this is a polynuclear complex with two different types of bridging ligands. We have the amide group, which will be known as amido group, and the hydroxide group, which will be known as hydroxo. So in naming this compound, it will be what? Mu amido. Amido will come before hydroxo because A comes before H. So amido, another bridging ligand, mu hydroxo. Then we have 4 amine groups on this side. Then we have another 4 amine groups on this side, making 8. So that would be octa amine. That's 8 amine group. Then we have 2 cobalt. This is 1 cobalt here, and this is another cobalt. That would be dicobalt 3 ion. This compound can also be named as mu amido, that's a bridging ligand, mu hydroxo, that's another bridging ligand. Then you have, instead of splitting this side of the compound and this side of the compound, then we can combine the two together, because we have what we have here is same as what we have here. So we can just name just one part, then we add what? Bis, then your square bracket. So we can, now since we've added bis, we can just name just one part of the compound. So bis tetra amine cobalt 3, then you close the square bracket. Thank you for watching this video. See you in the next video.